Okay, and so we start again, and to save a little time, I wrote the instruction. I move back up on the sheet from today, add I, S0, S0, 7. Okay? And again, if you look up add I, you'll see that that is an R format instruction. Okay, this is an R format, or I'm sorry, not an R, an I format instruction. Add I immediate. Okay? So an I format says I'm expecting an opcode, a little OP there. Then I'm expecting your RS, your source. Then the RT. Oh, better make that an RT. Which we could be considered as the second source or the destination. In this case, it's the destination. And then what they call the immediate, which in our case, that's exactly what it is. IMM. It is the number we're going to add. In our case, it's a 7. Also, I'm going to know by looking at my green card, the opcode is 6 bits, as always. I've got 5 for the RS, 5 for the RT, and then 16 bits for the immediate. And if I don't need them all, I'll just sign extend my number, +7 in this case, to fill them in. Okay, there's no chopping stuff off and leaving it off. I got to finish up with 32 bits. All right. So when I go to my green card, I find out that the opcode for add I don't have to go back to any other registers or anything. I'm sorry, any other columns. It's right there. The opcode is 001, 001, 6 bits worth, right? 0, 0, 1, 0, 0, 0. Okay? Then I look for the RS and the RT. You can flip your card over, you can check the back of your book, and you'll find out that this is the destination of the operation you're about to do. So this will be considered the RT in this case. Okay? And this will be considered the RS. There we go. So if I want the RS here, technically that's this S0. They're both the same. Maybe I could have done a better example, but that's all right. Okay. Then I want the RT. Technically, that's this S0. So I should put S0. And then the immediate is the number 7. Okay. Leaving my opcode, because that looks good, I find out that S0 is register 16. I'm going to end up using him twice. And then the number 7. Okay. Getting this down into binary, let me rewrite my opcode since that's already in binary, so that's nice. Now the number 16 in 5-bit binary turns out to be quite nice. Now what would happen if I had a register number that didn't fit into 5 bits? Somebody's made a terrible mistake. Because there's only 32 registers anyway, they're all going to fit in. If they don't fit in, we've got some more serious trouble. So they will fit in is basically what I'm trying to tell you. Okay? So here's the register 16 again. And now the number 7, written in 16-bit binary, basically requires a whole bunch of leading zeros. So to save space, I just kind of do one of these jobs. That means here's a whole bunch of zeros. And then I'll write out my last 4 bits. How about that? Because that's where the action takes place for the number 7. Okay. So now I have everything into binary, but as you've seen me do before, I need to divide it up into 4-bit chunks so that I can turn it into hex. Okay. Cut it there. Cut it there. Just making my 4-bit cuts. This is going to turn out to have 2, 3 cuts in it, and then that guy right there. Because I need to end up with 8 cuts. Okay. So let's write this. This guy by himself is simply a 2 in hex. This is another 2 in hex. This is a 1. 0. These guys are going to produce a 0, a 0, and a 0, and this produces a 7 hex. Okay. Now I have my 8 hexit, if you will, digit hex number, and this is the instruction add I S0 S07.